Kayla again. So here on this first function or on this first equation, what we can do, we can't actually take the derivative of a variable raised to another variable. So what we have to do is we have to take the natural log of both sides. So natural log of y equals the natural log of x to the 2x. So you can bring down the exponent. So it's now the natural log of y equals 2x times the natural log of x. And then we're going to implicitly differentiate. So it's 1 over y dy dx equals, take the derivative of the first one, 2 natural log of x, plus the derivative of the second one, 1 over, and it's going to be 2x. I'm going to put the 2x up there. And then all you need to do is multiply both sides by y, and you'll get your derivative. So your dy dx is going to equal 2y natural log of x. So 2 log natural log of x plus 2x. Well, I guess those 2's cancel out. I'm sorry. So it'd just be plus xy. No, that'd be, I'm sorry, that'd be x. So the x cancels out. So it'd actually just be 2y. Alright, so that's your derivative of the first one. So yeah, this is the derivative of ln, or natural log x, is 1 over x times the first one, 2x, so the x's cancel out. So it's just 2y. Okay? So here we're trying to find, I think it was dy dx, right? The second one. So what we're going to do is we're going to take the derivative of both sides with respect to x. ddx, ddx. The derivative of that is 2x plus dy dx. So it's just 1 times the derivative of 1 times dy dx, and it's 3y squared dy dx. So now we're going to solve for dy dx. I'm going to subtract dy dx over on this side. So 2x equals, I'm going to factor out the dy dx. So this side went away. We subtracted it. So now this side, it's just 2x equals 3y squared dy dx minus dy dx. So I'm factoring that out. So it's 3y squared minus 1. So now your dy dx is going to equal 2x over 3y squared minus 1. Okay? So now what we need to do is we need to implicitly differentiate both sides again. So we're going to use the quotient rule now. So this is dy dx. So we're going to do the derivative of the first one. So it's just 2 times the bottom one, 3y1, minus the derivative of the second one, which is going to be 6y dy dx times the first one all over the other one squared. Dy minus d1, and that whole function squared. That's our quotient rule. So our second derivative, we're going to plug in this into where our dy dx is, because dy dx equals this, and that's what we have right here, so we're going to plug that in. So it's going to be, I'm just going to do 6y squared minus 2, then minus, and this is going to be, it's going to be 2x right here, and then 6 is 24 xy, or x squared y on top, and then the bottom is 3y squared minus 1 right here, and then all over 3y squared minus 1 squared. And then this is your second derivative right here. So the trick was plugging in your first derivative in here when we do the implicit differentiation. Okay, we're going to take the derivative here. So dy dx equals, and this is going to be the derivative of the outside function. We're just doing the chain rule here. So that's going to be 10x and natural log of 5 over 1. That's the derivative of the outside function times the derivative of the inside function is 10. So you can just rewrite it as dy dx equals, well, the 10s cancel out, so it's 1 over x natural log of 5. All right? The second one, what we're going to do is we're going to take the derivative, dy dx equals, and all we need to do here is we'll do the product rule. So it's going to be 3 sine x, 3 to the sine x. That's the derivative of the first one, which is 1, times the second one. Now we have to take the derivative of the second one, which this is the tricky part. We need to, it's just going to be, and we're going to take the derivative of the outside function again. This is the same thing. It's the chain rule. So it's going to be the derivative of the outside function is 3 sine x, and then just the natural log of 3. And then that's the outside function, and then times the derivative of the inside function is just going to be cosine x. All right, and if we do, so dy dx is, I guess we can factor out a 3 sine to the x, so plus 1 plus natural log of 3 times cosine x. And that would be your derivative right there. All right, thank you for sending in your questions, and have a good night.